Okay, welcome to the third session and the second day of this course. We'll spend first, for sure, the first session on CMake again, then we can discuss what we will continue with. So let's first probably very quickly go through the modern CMake for the most important things again. So just to recapitulate what we did. So just very quickly, let's look at the example how the old-style CMake looks once again. So in the old-style CMake, we have functions like add library, include library, link libraries, add compile definitions, which are considered bad because this is what we usually don't want to do because we want to use targets. And we want to use the functions for the targets and set options and include directories and all of those properties for the targets. So, and another thing which is pretty bad in here is we do find package boost, and what we get from there is include and libraries, include directories and libraries, and we use them explicitly to set include directories and libraries. So what we usually prefer to do is we do, again, find package boost, but then when we link, we don't specify include directories explicitly with a full path, but instead we link against boost : program options, boost : boost, boost : whatever. And the other thing is that instead of add compile definitions, which is a function on directory level, so it holds for all targets that are created in this directory, we prefer functions that are specific to a certain target. So here we set so we compile with -d use CUDA for the target mylib, which is preferred because then this is only used for mylib, and we can also have other libraries in the same directory which might have other compile definitions. Exactly, and this is the other thing. There are two functions, the functions which are usually considered bad, those here, the directory scope. So you should not use include directories, the functions include directories, link directories, set compile options, I think, set compile definitions and all of those. But instead, you should use all the functions which have target underscore in the beginning, like target compile options, target include directories, and all of those functions. So they should really be preferred. And there is usually not much reason to use the directory scope or the ones without target. Exactly, this one is probably also something which I can quickly mention again. There are build requirements, there are usage requirements. Build requirements are things like include directories or defines that you want when compiling the library itself. So when you compile lib1.cpp, like here, you will need to use all the defines that are build requirements because they are required to build. So d1 is private, so it's here in the command line with d1. Then there are usage requirements, which are, for example, defines, which are needed for the users of your library. So in this case, I have lib2, which links against lib1. So because I'm linking against lib1, I'm a user of lib1. And the usage requirement of lib1 is, as you can see here, defining d3. It's an interface property. So when I compile lib2, I do -d3. And the third option is the public, like the orange one here, the d2. And the public is a build and a usage requirement. So compiling with -d2 is needed to compile lib1 and to compile lib2. So it's build and the usage requirement. And just don't use public for all properties. And this is the list of functions that you should use. They all begin with target underscore, except add library and add executable, which are the things that creates the node in our graph. So they create the nodes in this graph here. We have the executables like sample9 unit test, and we have the libraries like gtest. And just use functions with target underscore. Yes?
What is add library interface? Is it like an empty target without output, just for definitions? Or?
The add library is with interface. An interface library is a library which has no sources. So usually you can use it for header-only libraries, or just as a collection of usage requirements. So you have some library, some kind of library which is just defining -d something. But for sure, you always use them for header-only libraries. So this is this one here. And yes, then very quickly to explain the two modes again. There is in CMake, when you do find package, there are two modes. So a library can be in kind of two modes. So you might have a library which uses CMake itself, and you wrote that library with CMake. Then you can use it in config mode, because then you can make this library in a way yourself that it supports CMake. And the other mode, the one that we discussed yesterday, was the module mode, which is for libraries which usually you did not yourself, which are not built with CMake, and which don't have this logic to support CMake by themselves. So you, as a user of that library, need to make that library somehow. You need to use this library somehow in your code. So you need to set up a file which finds this package, or you need to write a file which is usually called, or it is called findBoost.cmake, and it has the logic in there. How do I find Boost? So it's going to look for some headers or some files or some library names, and it's just searching or guessing where these things could be. So you need to have this file. Let's look at the final example. This one here. So you need to write such a file. In this case, we are writing a file to look for the library input. So you have FindInput.cmake, which is this file here. And what you do there is, in the beginning, you're going to ask the package manager if this library is installed as a library. From this, you get some hints where this library could be, if it is somewhere. So you're going to look for a file which is called libinput.h, which you know needs to be somewhere. And you know that the path where this file lives in is the include directory of input of this library. And as a hint, you use the thing that was returned by the package manager if it found something. And you're also going to look for a library, which is called input.something, and use this as libinput library. Then you have this find package handle standard args thingy, which takes care of handling the arguments to the find package. So in the find package, you can provide required, or you can provide required, or you can provide a version, or whatever. And when you call this find package handle standard args, it will just take care of all of that. So it makes sure that required vars, that all those variables are defined. It will take care that this version that was found matches the one that was required. And if everything is fine, it will set libinput_found. And finally, this is the most important thing, is that in the end, we will create the library with the information that we found. So we create a library, libinput : libinput. So we always use this namespace in front, libinput : and we set some properties on it, like include directories, compile options, or whatever. Very quick recap. Very quick of what we did yesterday. Questions from yesterday? No questions. Yes, one?
I mean, it's probably very microphone.
Microphone.
It's probably just red. So.
How to turn it on?
There is a button, I think. I don't know.
Mute.
Yes.
I don't know if you're going to mention it, but when I build my library, I need to look for third-party libraries, and when I export my library, I need to look for the same third-party libraries. So what is the best way to not write the same code twice? Because, I mean, you just showed us this, how a find package would look like, and there you look for lib input, for instance. But when I build this thing, I also look already for lib input, so I would have the same code twice in my CMake build system in the end.
So you mean when you have a library, and this library needs a library, and those both have the same dependency? Or
I mean, for compiling my library, I need to look for lib input when I want to compile it, and then to write the find package module CMake, I also need to look for this lib input.
But when you compile your library, you will do find package input, and when you do that, you will call this thing here, which will search this library, right? And when you compile input itself, you don't need to find it because you are input. So you're just going to install it somewhere.
No, so your lib input is not a third-party library in this case?
Lib input is the third-party library, yes.
But not in this case. In this case, you explain how to write this find package file. So in this example, we will not.
But you know what I mean. So if I depend on boost program options, for instance, then I need to look for find boost, right?
Yeah.
So I have in my CMake list.txt at some point find boost, blah, blah, blah. And then if I write this find package module, I do exactly the same again because I still depend on boost, right? Because I cannot run with, I mean, you cannot compile without boost, and then I...
But it's not a problem because it's one line, find package boost.
But it's still... Yes, but I have doing the same thing twice. If I add a requirement on one side, I have to add it on the other side again.
Yes. But he will cover it, how to do it properly in the next session.
Other questions? Okay, let's then look at the modern way, how we can install libraries. So what we are going to explain here is the other mode. So you write a library. This library supports CMake. You want to export those targets and use those targets in another library. So kind of you write boost, you write a CMake list of boost, you export targets, and you use boost from another place. And how are you writing then the logic that is needed for find package? So what we are going to do is basically the first two things there. Okay, I didn't update this slide. We are going to look at how do we install a library. Installing means copying the things to the right place. And the second thing is how do we export the targets and make them available to find package so that you can use them in another library. What we need to know when we are going to install a project is we need to first know what are we going to install, which files, which directories, what are the permissions that on those files. We need to know where are we going to install it, which means we need to have some directory for headers, some directory for libraries and for executables, and maybe other things. And the third thing is we don't need to install it only, but we also need to find it again. So we need to have a way how we can find it again, and this is the exporting. So let's suppose we have this mylib again, like before. We have find package boost, we have the library mylib, and we link again boost. In this case, we are not linking again boost program options, but only the header-only part. And we have some include directory. So what we need to do first is we need to install the target itself. So we mark the target for export, which means that we say that this target will be copied into some logic to find it again. And more importantly, for the beginning is that we specify some destinations where we are going to find it. So we say, I think this is coming here. We are going to say that shared libraries, like the library destination here, should be in CMake install libdir, which is given by the system is certain, so its default is, I think, set to the prefix /lib or lib64, depending on your system. We are going to provide a destination for static libraries and executables. And we need to explicitly copy also the headers. So it's another install where we are going to copy the whole directory include all headers that match the pattern.h star, so also .hpp, and we copy them to CMake install include there, which is the prefix /include/mylib. So there we are going to copy the include directory. There are also other versions of install directories for directories where you can, okay, this is this one, but where you can also copy single files or executables or the targets as the one above. And you can include these GNU install dirs, which will give you the right defaults for the CMake install lib dir. So it will give you user include for include directories if nothing else has been specified. And so very important here is you need to copy the includes separately. So the install targets, this one will only copy the libraries and the executables. And if you want to copy the headers, it needs to be a separate install. This is going to change at some point. So it's, I think, so in the current CMake version, there is some support for also installing the libraries together with the install targets, but it looks not really like this is already finished. So currently, we are going to copy the headers explicitly with install directory, and coming versions will have a way to do it differently. Then you can just say install targets, and you can also give a public header destination, which will be exactly what you want. So you will only need one call to install targets, which will just copy all the libraries, executables, and headers to the right place. Okay. So quickly to this slide again. Here we'll have this export thing. So the export, this is just an identifier. So you say you have several targets maybe, and in the end, you just collect all the targets that you want to export, and you give them the same name. So in this case, you have probably a target mylib. You probably later have at the second place, you have a mylib2, and you just pass everywhere the same mylib-targets. And in the end, you will export mylib targets, and this will be made available to the other find packages. So what you do later then is you do install export mylib targets. So this is again the same identifier. You say, I want to create with this a file which is called mylib-targets.cmake. There it will produce a file where all the targets are created, like in the other versions. So it will create add library, unknown imported. It will set some properties like you defined it. And you can give it a namespace. The namespace is like in boost : boost. It is the thing in front. So you should always use something like library name : where the : is convention only, by the way. And you give it a destination where you want to copy this file. So what this does, it generates a file, mylib-targets.cmake. So the name is coming from here. In this file, you will find something like this. So it will create add library lib : mylib, like we did it manually in the other example. Static imported because it was a static library, imported because it's an imported target, and it will just set some properties on this libmylib, like the include directories that we've seen before, and also the link directories, link libraries like boost : boost. Questions until this here? Yes?
Just one tiny one. When you use block expression, sorry. So I was just wondering, when you use glob expressions during the
installation to install from a directory, will the generated make file keep track of changes or not? Like if you split an header into 2 headers, do you have to explicitly call CMake again, or will the make file understand that for you?
So the install, when you do make install, it will always repeat the whole install again. So it will keep track of those changes.
Okay, even if you use just glob expressions on directory, like you say,
Yes, yes. But in there is also another command, like which is called file, where you can kind of, I mean, maybe there was the use case like I want to find all my unit tests. Then you can say, okay, I get my sources with this file, and there you can also use globbing. But there is a problem because this one is not updated. But in installing, it's okay. But not when you get the sources with globbing. There it's not okay.
Thank you very much.
Which is why it's not that recommended. So there is a workaround for that. There is in new CMake versions, there is also for this file. You have a way to get it updated, but there it needs to check all the system again, and which is probably bad performance. But for the install, there it's fine.
Okay, thank you.
Okay, so here is one problem. The generated file, mylib_targets.cmake, has an absolute path, which is not that great because when we copy the library, it will break. So we cannot move it around. So what is very important when you export libraries is instead of, where was it? This thing here. You have target include directories, mylib public include. Include is kind of an absolute path, or interpreted as an absolute path. And there you need to make sure that you use the right include directories. And this is very important to do that because otherwise you get absolute paths. So what you need to do there instead is when you specify the include directories, you can say if I'm in the build interface, like this thing here, then my include directory is the source directory /include. If I'm in the install interface, so when my library was installed, then it's just include, which in this case is always relative to the install prefix. So include, when you export libraries, you always should use build interface, install interface, and specify it separately, because otherwise you get absolute paths and your exported target is only useful at the place it was installed at that place, at that moment. And what happens if you use it like install interface? So when we now install it, what happens is it will, from this install interface :include, it will create this thing here. So it will add an import prefix, which is just something, which you can also change. And everything is relative to this path. So the installed library is relocatable, and it's just relative to some prefix. So every time when you install a library, you should use build interface and install interface for include directories. Let's quickly look again at how the config mode works now. So when you do find package mylib, so the config mode is the one that's not the one from yesterday, not the one where you use an external library, but the version where you have a package or a library which uses CMake, you install this thing, and you use it from another version. So in this case, find package is looking for a file mylib_config.cmake, which we have a look right now. And you can give this find package a version number. And the nice thing about this is if you have several versions of mylib install, it will just continue looking at mylib_config.cmake until one of those ones matches the version that you are looking for. So it's kind of asking all of those mylib_config.cmake, do you provide the library and the version that I want to have? If yes, I take it. If no, I'm going to ask the next mylib_config.cmake. Yes. So how this looks like is, so you need to write, so when you install, if you want to make your library available to other projects, you need to write this mylib_config.cmake, and you usually do this with this configure package, the CMake package config helpers. So usually your library will have a file which is called mylib_config.cmake.in, which is kind of the mylib_config.cmake that you will have in the end, but with some placeholders. So everything which has an at in here will be replaced. So these are placeholders. You are going to look for boost. You configure the mylib_config.cmake.in from this file here. You want to fill all the placeholders and copy it into the binary directory. And you say that in the end, you're going to install it in CMake install libdir. And in the second step, you also need to copy the generated file. So in the first step, you are going to fill the placeholders, everything which has an at on the right-hand side. And in the second one, you are going to copy this generated file to the destination. And what you do in this mylib_config.cmake.in is first you include some helper, but then you kind of need to create the target there again. So you need to first let's look at the include. So what CMake will do when it's going to look for, so when you in the end you do find package mylib, it will going to kind of source this file here, the generated file from this. So in this file, we are going to include for sure mylib targets.cmake, because in mylib targets.cmake, we are creating our targets. Like we have seen before, we are going to export the targets, and we are going to include them. So if we include that file, in the end, we will have the libraries created, or the targets created. What we also need to make sure is that everything which is needed in that library is also available. So we need to have boost available, because mylib links against boost, so we need to have boost available. We are going to find boost. We are going to find it with FindDependency, because it's in a config file, so we don't use find package here, we use FindDependency, but actually it's more or less the same. It's not quite the same, but the detail is not that important. And with this file then, the file that is generated from this, we created the targets that we need. Another thing is we need to create another file, which is mylib_version.cmake. Mylib_version.cmake is the file CMake asks to check if the version is compatible. So if I do find package mylib with a version number, it will look for this file mylib_version.cmake, it will load it, and by loading this, it will check if the version that is provided by this file matches the one that I required. So I say here, write me a package version file called mylib_version.cmake. This version that I'm going to install here has the version project version, and I require some compatibility restrictions. So in this case, I require that the installed that when I do find package boost with 1.2, the found version needs to have at least version 1.2, and it needs to have a 1 in the beginning. So this is same major version. There are different versions, like any newer version, say major, say minor, or exact version. And also this file needs to be installed. So there's probably now much confusion. So let's look in the end of what we get all together. So this is how do we export mylib, the one example that we always looked at. So this is the file, the normal CMake lists.txt. So in the normal CMake list.txt of the library that we are going to export, we need to have boost because we are going to link against boost. We add the library. We add an alias. This is just if you have. It's not that I don't mention this for the moment. We are going to link against boost. We set include directories with the way that I explained before, so with these two separate interfaces. which is basically what we did yesterday, more or less. So we are creating targets. Then, in the second step, we are going to say what we are going to install. Installing means copying what we are going to copy. So we are saying, let's copy all libraries, all binaries of mylib, of this target mylib that we created above. And let's copy these things into CMake libdir, libdir, bindir. So this is just copying the libraries, and it says that I'm going to export this into a file. Then I also install the include directory, the include files. So it's just copying everything which are headers. And as the third step, I'm going to export the file. I'm going to export the file. So what we did until here is I'm just copying things around. And in the third step, I also need to make sure that the thing that I exported can be found again. So I need to write a file where my target will be defined later. So I have to install export mylib targets, which creates a file where my library is defined. So it's creating this imported targets then there. Then there are two things missing. I need to write the config file. The config file is kind of the main entry point of the thing that is called by find package. So this one is generating this main entry point where we include all the mylib targets.cmake. And you need to have the version file, which checks, when you do find package something, which checks that the version that you required matches the one that you provided. And for sure, this is much information, and for sure, no one of us, and me neither, can write this from scratch just by knowing it. But I think it helps to have an example where you can copy it. And what it does is it is going to install mylib config. It can be found with find package mylib. And you can also just copy it around in the way you want it, this installed thingy. And yes, this one is probably also important. If you installed it now, it will have, in this case, a CMake folder. So if you install it in home, there will be a folder home lib CMake from this thing here. So CMake install libdir is home lib and CMake. So there will be a home lib CMake config.cmake. And if you now want to call CMake using that library, you will need to specify the path to that config file. So you are going to call probably CMake ... and you just say mylib _dir is that path. This is one way to set it. You can also set it with CMake or with an environment variable, but this variable needs to be specified if it's not in the default location. Yes, I think. Other questions? Yes.
Can you go one slide back?
Yes.
Wait. Battery empty now. Okay. So no microphone. Anyway, you have, when you do the add library, you actually marked this already. The slip column mylib.
Yes.
Why? Because you add down there explicitly the namespace again. And I understood it before that this namespace would actually put it then inside. So
this
when
is
you do the install export, it would create your namespace plus the name of the target. But
yes.
The name of the target for you is now lib : mylib. So I would imagine that CMake now has lib : mylib as exported name.
Mm-hmm. Okay. The reason for that is, so first, this line here has nothing to do with exporting. So
right, but it gives it a name.
It gives it a name. But so you're going to export the first. So you're going to export mylib, like this first line. This is what you're going to export. So you do here install export targets mylib, not lib colon mylib. So second thing is the namespace that you specify here. This is only relevant in the file that you're going to generate. So you're going to generate a mylib-targets.cmake. There is a net library something. So in this file here, in the CMake list txt of the library itself, you won't have, from this you won't get anything. This is just creating a file. So this line here causes for sure no problems when exporting the library, because there it's not used at all, because I'm exporting this thing here. Why we have this line is for another reason, because there are several ways how you can use CMake libraries, so you can export them, or every library should also be in a way that you can just add them as a subdirectory in your project. So if you have Google test, you can either do a find package Google test, or you can just copy the folder Google test into your directory. And it should do the same thing. So when you do find package Google test, it will probably provide you a target Google test : Google test. If you do add subdirectory Google test, it should also have this thing. And this is why you add this line here, because then you have this library also available. That's the answer to the question.
Yeah.
Okay? Other questions? Yes?
Just one easy question. If I have a library which depends on other libraries, for example, would be a good user to put everything inside one CMake file, or I should create different CMake file for each libraries? Which depends?
Yes, so the question is if I have a library.
Yeah, for example, if I have a library like Pastix, which is a linear solver, then I have to link it with another library, which is a graph envelope. So I put everything in one CMake file.
Okay, the question is if I have one library, or if I have several libraries which have dependencies among each other, should I put them into one CMake project, or should I have several CMake projects, right? So I think that you should have for sure several CMake versions. CMake has several projects which are independent, but they should all be kind of in a way that you can also add them as subdirectory. So if you have one top-level project which has several dependencies, you can either add the sub-projects as subdirectory, but they should be standalone, so you can plug them into different projects. But they should be standalone, but you can just add them also as in a subdirectory. So each dependency should be standalone, but each dependency should be in a way that you can just add it as a subdirectory as well. I think that should be the way to go. Other questions? Okay. Yes. Oh, okay. Probably 2 slides more, I guess, because this is what we just discussed. External projects can be used should be usable as a subdirectory. So if you have Google test, it just works as a subdirectory. You can just use it like with add subdirectory. And this is one of the most important things. Every CMake project should act. So if you provide a config.cmake, it should behave the same way as you add it as a subdirectory. And you should never assume that your project is the top-level CMake, because you might always be included in another CMake. And yes, there is this fetch content where
So this is particular for John. John asked this question yesterday, how to do it today, and maybe you can introduce it to John.
Okay. Okay. So Google test, there are several ways. Let's make it specific to Google test. There are several ways how you can use Google test. One way is you can have it as an external project somewhere. You do find Google test. It will provide you the Google test things. It's probably not the best way, because Google test is a very lightweight dependency. Second way is you just add Google test as a subdirectory, if you want, with a Git submodule or Git whatever, which also works. Or the third way is this one, which is kind of, so what it does is it downloads Google test if it's not already downloaded. So you have this fetch content, and fetch content, in the fetch content you have two functions. One function is declare. In the declare, you give the thing that you're going to download, like Google test, you give it a name, Google test. You say, how do I get it? You get it from a Git repository, and you say, I want to get the tag release 181. And what it does is, in this case, it's just declaring, and then you do a make available. So you do fetch content make available Google test, and this will download Google test. So what this is doing is, when in the configure step of CMake, it's going to download Google test. And it will provide you all the targets, and you can just use Google test the way it is. It replaces kind of external project add, which behaved differently, because external project add was downloading and compiling during building, which is slightly bad, or slightly worse, because if it's doing the download during build time, there are several problems. One is if you have no internet connection, you need to have an internet connection during building, because it will always check if Google test is still up to date. In this case, it's just downloading it during configuring, and if it's downloaded, it is there. So as long as you don't change the Git tag, it will always be there. So this one is probably the nicest way how you can integrate lightweight external dependencies like Google test. Yes?
So does it download?
John?
It's back.
Okay, so it says the fetch, it says, which line is it? It says, fetch content, make available, downloads and builds the dependency, if not yet done, and adds it with add subdirectory. Now, does it download it and build it,
So
and then add it as a subdirectory, or does it download it, add it as a subdirectory, and then include it in your main build?
it's the second one. So it downloads it during configuring into a folder, and it just does add subdirectory. So instead of this fetch content make available, it's kind of replacing it with add subdirectory Google test, and then it behaves the same way as you have it as a subdirectory.
Okay, so supposing you were to have grid tools, your project, for those listening, your project is grid tools, you've got release 1.0. I decide I want to use grid tools in my project, so I put fetch content, make whatever, fetch content, declare grid tools, put the Git repo, put the tag in. Now, inside your grid tools, you've got lots of options. And you're going to say, do I want to build with this option? Do I want to enable that option? Do I want CUDA this? Do I want KNL compatibility? Do those options become visible in my master project, which is now downloading you as a sub-project? Do I see those options in my CMake?
Yes, you should, because it's really doing an add subdirectory. It's doing nothing else than an add subdirectory.
Now, does it handle name conflicts? Supposing you've got add option X, and I just happen to also have add option X in mind, but it does something completely different.
So this is a cache variable.
So what I want to know is if it will handle things like putting your options into a namespace for grid tools and so let's supposing I download grid tools as a sub-project and it's got use CUDA.
So you're talking about cache variables, right?
Yeah.
So no, cache variables should always have a prefix.
So do you, as a developer, prefix all of your variables with grid tools use CUDA,
Yes.
grid tools use...
Cache variables should have a prefix.
So you do, but it doesn't enforce that. No. I've been doing this for years on a not nicely like this, but informally. And every project you download says use CUDA. And the problem is that use CUDA, you might want to enable CUDA in one project, but you might want to disable it in another one for whatever reasons, and they always conflict. And I want to see a way where it adds a namespace. If you've done grid tools, that's great. But it would be nice if there was a way of enforcing it at a...
I don't think it's possible. At least I don't think it's possible in CMake too.
Are you using this particular fetch content in your
I
development?
don't think we use it all. I think we have it as a subdirectory. I think, right?
It's pretty new, so
Okay, so that,
I think we won't use it the first time for preparing for this.
okay, fair enough. Because my next question was going to be, what problems have you found that I'm going to, because I will definitely use this, because I've got one project where
So
I have
I'm pretty
something
sure
like
that
11
it's okay.
sub-projects, all as subdirectories, and resolving all of those is a real pain. And
I think the reason it exists is that, I mean, I think it should be pretty major because it's kind of I think it should somehow replace the external project add, which is kind of
yeah, that
had
was always
some
broken.
problems like this. It's always updating. So this is why I think it should be pretty stable. And it's not that new. It's something like 3.11. So it's not that new.
In case anybody's curious, the reason why you'd want to do this, one of the reasons why you want to do this is because, let's supposing you have very specific compiler flags for a machine which you've set up for your project, and then you need to build 3 other projects which your project uses, but they all happen to be CMakified. If they're all CMakified, you can make them as sub-projects in yours, and then when you build them, you can make sure everybody gets the same compiler options and flags and all these kind of things, and it's all really cleanly set up. So seeing this kind of formalized.
And there are several nice things about it. One is that if you have several sub-projects which all use Google Test, and they all use this fetch content thingy, it will just download it once. This is one of the nice things. And the other thing is that it's really quite customizable. So the one I wrote it here with this declare make available, this is the simple version, but there is a more complex version where you can really customize much more, like how it.
You mean like you can put like destination of where you want Google Test
Yes,
to appear in the
exactly.
tree
So
and
this with this fetch content populate, you can really, and then you also do the add subdirectory manually.
I
So
can-
you
I
need
can-
to do it yourself
I can
then.
delete a ton of macros that I've got that do all this now. And
Yes. Here's
So,
questions.
I was just wondering, how would that thing deal with transitive dependency, one, and how would you deal if you want to vendor something that is not CMakified?
So the
You know,
first,
I'm trying to make a case for our tool, because of course this is limited.
so what was the first? Can you say first question again?
The first question again is, how do you deal with transitive dependencies? So if you have a dependency which is not as simple as Google Test, but brings in other CMakified dependencies depending on which option you use.
So for sure,
Would this content, would this like feature deal with tuning them and keeping track of all the things in the graph up to level 1?
You're talking about fetch content or about the...
Yeah, this kind of fetching your dependencies.
I think if I understand Massimiliano correctly, then if I say enable grid tools in my project, and so I download grid tools, but grid tools has an option which is like CUDA on or off. Now if CUDA is on, it needs version something of Google Test, but my code needs something else of Google Test, yeah? So you have these transitive and conflicting.
so
I mean, it
I
probably just doesn't
think
work,
there might be one problem because, I mean, one thing related to that is the thing that I mentioned before. If you have one library requiring Google Test, it will always, I think it will use the first one or the top level thing will give the version that is finally used. So there is not that much control of which fetched content will be used in the end. I think it's the one that was first requested, because it doesn't want to download Google Test twice or 3 times.
Okay, so, yeah. So basically, this could work for, I don't know, a simple dependency
Yes.
which doesn't bring in other dependencies and are CMakified.
Yes, I mean, other dependencies, if your included thing uses CMake again and uses fetch content again, this should work if it uses another
Okay, but if you have
dependency.
two, which brings in, so you're not doing, let's say, a constraint resolution of stuff. If you
No, it's
Okay.
not really doing some real fancy resolution of dependencies.
Yeah.
But what you can also do is, I mean, you said that you can only include CMakified things. You can also include other things, but I mean, you can also fetch some some data that you want going to test, for example. So if you have some test data, you can also fetch content them and just extract them at a certain place. But you can probably not do a make file. You build something which only uses make file and assume that you can build it. But you can download artifacts with it.
Yeah, so I'd say you should only use it for simple dependencies because you're basically bypassing a package manager who should do the right thing. I mean, if you have a complicated dependency, then you better install it with a package manager, I'd say. Yeah, and not fetching.
I would agree.
Exactly. So, yeah. So I don't think you should fetch all your dependencies with fetch content.
I mean, there is this CMake package manager, but I don't think that's the right solution. Hunter, or what is it called? I guess it's called Hunter or something like that. There is a CMake package manager, but okay.